All right, so welcome to this next video here. We're going to do another uh, two sample t-test. Here we're using our ad spends. We've got a series of performance of two advertising campaigns with impressions. How many of those are completed viewed impressions? How many of those completes are clicked? Then of those clicks, how many people installed the app? And then what was the average revenue per thousand impressions generated, right? So ERPM is that average revenue per thousand. We have that for strategy A and strategy B. We have that for each row across a series of dates in June, right? So we're going to go through here and we're going to focus on this revenue, right? So just to make things easier to view, I'm going to grab these columns and just hide them, right? So again, we're going to focus on the revenue across each of these guys. So just to make things easier to see, right? So we've got strategy A, strategy B, we've got the dates and the revenues for each of those, right? And so if we've got strategy A and we've got strategy B, right? So again, before, let's look at our count, let's look at our min, max, average, and standard deviation of those guys, right? So equals the count of G colon G, colon. This is going to be the count of O colon O, right? And then the min of G, the max of G, the average of G, and the standard deviation of G. And we'll just do that for strategy B as well, right? So the min of O colon O, the max of O colon O, the average of O colon O, and the standard deviation of O colon O. Oops. Okie data. All right. So we'll see here we have 30 data points, or our sample is of 30 observations for each of the two strategies. It looks like strategy B had a little wider range. The min's a little bit lower, but the max is higher. And it had a larger average revenue. With standard deviations, again, given the wider range, a wider standard deviation for B. Right, so here our goal was to test this new strategy, right? So we do this experiment, right, directing part of our traffic to strategy B and part of our traffic to strategy A. And we see here that yes, on average, strategy B generated higher revenue, but more uncertainty in that revenue and also a much larger range, right? So we have this question really, right? Is B better, right? That's really our question, right? So our null here, HO, is kind of that the means are the same, right? So strategy B, no different, right? B, no different, right, than A, right? And now we think about our alternatives, right? So we could have, means are different. That would be a two-tailed test. Or, again, assuming here we're trying to test our strategy A, right? So mu of B is bigger than mu of A, right? So here we would have a one-tailed test, right, where we're trying to sort of, whether or not we can conclude that strategy B is outperforming strategy A. Right, so we're going to use the t-test function, right, given that this is a two-sample version versus a single-sample version. Right, so our p-value in this case, right, let's do the t-test. Right, let's grab A revenues. Let's grab B revenues. All right, and we could do our one-tail tests, right? So let's hypothesize here that, as our alternative, that the mean of B is going to be bigger than the mean of A. And again, let's do our unequal variances, even though we have samples of the same size. And we see here that the p-value is bigger than 0.05. Right, so with a traditional two-sample t-test with unequal variances, we could not reject the null. But one of the things that we have here is we have two samples of equal size, so that opens the door for a paired sample. And then, because we have the observations on each day, right, we have June 1st data for both strategies, if we could argue that ad performance on June 1st is different than ad performance on June 2nd, we're really concerned about how they performed on each day versus on average across all the days, right? So what we could do here is we could do that paired test, right? And so now we do the same steps, t-test of strategy G, data, the first vector, data of our second vector. But now under, still going to do a one-tailed test. Oh, I got to put the test in here, t-test. Right, so now I'm going to do still a one-tailed test, but the types I'm going to do one for paired. Right, and so now when we do that, so now the p-value is less than 0.05. So here we could reject the null, providing support for, all right, so I should just, for completeness sake, can't reject null. Here we reject the null, p-value is less than 0.0, providing support for our alternative in this case. And we did this one sample t-test here where mu b is bigger than mu a. Now just for interest's sake, right, I'm going to insert a column here. And what we're going to do here is E RPM of B minus E RPM of A. Right, so we're really looking at the difference in daily expected revenue. So this guy minus this guy. Right, and we copy that down. And if we look, we just copy these guys over here. And this again was, I'll just copy this header over here. So here again, 30 observations, the difference between the mins, right? Point negative, well, not necessarily, but the smallest of the difference is minus 0.37. The largest is 0.4. The average is 0.14 again. So the mean of the differences is the same as the differences in the means. And then a standard deviation a little bit lower than the standard deviation of either of those, again, because we're working at the difference. And so now, here, instead of, again, our goal is, we argued in the paired test that we're really talking about how they perform in a given day, right? And so what we could do now is a single sample t-test, but instead of focusing on strategy A versus strategy B, we just focus on the difference on their daily performance, right? So we could do a single sample t-test on this guy, right? And so now our standard error is going to be equal to our standard deviation divided by the square root of our sample, right? And our test statistic, right? Basically here we're testing whether or not this difference is 0, right? So if the means are the same, then the difference should be 0, right? So our test statistic is going to be the mean minus 0, right, divided by the standard error of that estimate, right? And that's going to be 3.32. And so now if we look at the p-value of our one sample, right, so that's going to be t dot dist, right? Okay. And so now we could either do a one-tail, two-tail, right? Here we're hypothesizing that, same as before, that B better than A. So we would expect that this mean is greater than 0, right? So let's do our test statistic and a one-tail test, but the right tail. And our degrees of freedom are going to be 30 minus 1, right? And the cool part here is that these are going to be the same, right? So our single sample one-tail test on the difference is the same as a two-sample paired t-test, right? So this is the nice part about these t-tests, is that this guy is actually just this guy. So you can either go through the steps and do our one-sample t-test, or you can just do our two-sample t-test, but realizing that it's paired, right? And we see here the value of the paired in that when we're looking at these differences, because there's a lot of variance in individual samples, right? A lot of variance here, the standard deviation is quite large, the range is quite big. If I don't do a paired test, I don't reject the null, right? Because there's more variance across the days than there is variance across the tests on a given day. So we don't reject the unpaired test. But when we control for the variance across the days by focusing as a paired test or on the differences, then we do reject the null, right? So this is, again, we're also going to reject the null on this guy as before, right? So we get some sort of key insight here into the why we might use this paired test and some of its coolness. That